Okay, so hi everyone. Today we're going to be talking about subtopic 2.4, okay, which is the next subtopic. Then on Friday we will talk about the last subtopic. So I plan to finish the entire chapter by this week. Okay, by this week. The last two sections are actually mostly more towards calculation. The heavy stuff is done. Okay, the heavy stuff has been covered in 2.1, 2.2, and 2.3. So I'm just going to revise again or just recap again what we have learned. In case some of you during the 1 week holiday, everything you have forgotten. So we're just going to recap so that you have kind of an idea of what has been happening so far. Okay. So first of all, in 2.1, we learned what current is. Okay, the main thing about 2.1 is introducing you to what current is. And current is the rate of charge flow. Okay, rate is because it's over time. Okay, and then charge flow is because it's denoted by Q. And we also learned another formula, which is Q equals to the number of electrons times with the charge of one electron. So that's basically it. Okay, so if anything from 2.1, take away this, the current is the rate of charge flow. Okay, the definition. Okay, kadar pengaliran cas. Okay, is what current actually is. Then, in 2.2, which was the heavy subtopic, okay, we learned a lot of things. We learned firstly, what is potential difference, okay, and then after that we connected it to Ohm's law. Okay, and then Ohm's law got two sentences. If you don't remember what Ohm's law states, remember that there's two parts to Ohm's law. One is the relationship, okay, and then the second one is the conditions for the relationship. Apa syarat untuk relationship ini valid, okay? So there are two things about Ohm's law, so it's good for you to recap again. Later you can write it down in your notebook or wherever. Okay, what is the relationship and what is the condition for the relationship to happen? Okay, and then of course we related it to this formula, which we are going to use very heavily today. Okay, which is V equals to IR, the potential difference equals to the current times with the resistance, or the resistance equals to potential difference over current. Doesn't matter. Okay, as long as you remember one or the other, it's fine. Then we went on to series circuit and the parallel circuit. Sorry, I'm getting out of frame again. Okay. Then we went on to series circuit and parallel circuit. Okay, and you know that series circuit is where, let's say, the resistors or the bulbs are arranged one after another. Okay, whereas parallel circuit is they're arranged on top of one another. Okay, something like this. And there are a couple of things that we learned about this one. Series circuit, we know that the current is the same. Oh dear. Okay. Current is the same. Whereas for parallel circuit, the potential difference is the same. Okay, I'm going to leave it here as it is because the resistance, how to count the effective resistance. Okay, R1, R2, R3, ini semua kita sudah cover. But I just want to note, okay, I just want you to note for today's lesson that in a series circuit, okay, the current must always remain the same. Okay, for all three resistors, doesn't matter whether the resistance is big or resistor is small, the current is always the same. The thing that changes is the voltage. Okay, and we find that every time it passes through certain resistors, the voltage will drop. Okay, until the final resistor, the total voltage will be zero. Okay, and then it will go back and then it will gather all the energy and come out again. Okay, but for today, before we start 2.4, okay, I want you to bear in mind two very important things. The first one is the formula for Ohm's law, V equals to IR, because we will be using this today. Secondly, is that in a series circuit okay, the current is the same. Okay, there's two very important things. Once we get this right, then we can start, okay, with this 2.4. So in order for us to learn 2.4, we need to understand, we need to remember again when we were talking about Ohm's law. Sorry, I'm looking for my eraser. Okay, when we were doing Ohm's law, we had this experimental setup. Okay, so I'm going to run this off. If you remember when we were doing Ohm's law, we had this experimental setup. So yang ramai orang complain, so the battery rosak don't know what, kan? Okay, so you have the battery and then it's connected connected to the ammeter. And then over here, then you have this funky wire, which is the constant wire. Okay, and then you have switch over here. Oh, sorry. Usually here is what the rheostat. Rheostat over here, constant wire, and then you have the ammeter. Okay, and then connected parallel to the constant wire is the voltmeter. Okay, so this is the Ohm's law setup. Okay, and we know that in this setup, if the switch is off, okay, if I turn off the switch, misalnya the switch ini terbuka, there will be no reading here, there will be no reading here. That's logical. Okay, that's logical. Okay, if I turn off the switch. And if I turn on the switch, okay, if I turn on the switch, then here you will have a reading, and then here you will also have a reading. Okay, but for today's purpose now, I'm going to add another component to this. Okay, let's say I turn off the switch first. Oh, overshot. Okay, let's say I turn off the switch, and now I attach another voltmeter here. Okay, and I'm going to use red color because I want you to notice the difference now. Okay, so if I turn off the switch, sebelum ini we've learned, if I turn off the switch, this one no reading, this one no reading. Okay, that makes sense because the circuit is broken. Okay, but if I turn off the switch, this voltmeter will have a reading. Okay, ada reading. There is going to be a reading. Okay, for this voltmeter lah. Okay, for this voltmeter. And secondly, when I turn on the switch, okay, when I finally turn on the switch, okay, this ada reading ini tetap ada reading, but the reading will be smaller. Okay, the reading will reduce, and the reading will be the same as this reading. Okay, same as this. Okay, that is what you're supposed to expect when we go back to school, if we ever go back to school. That's what you're supposed to expect when you go do this experiment later. Okay, you will find that this reading here will suddenly become the same as this reading. So why does this happen? Okay, we need to ask ourselves, kenapa bila kita off the switch, okay, when we off the switch, okay, why is there a reading over here? Okay, and what reading is this? Okay, so this reading is what we call the electromotive force, okay, which is what we're going to talk about today, like the electromotive force. So I'm going to show you the slides for this. Just give me a while to show you how the slides will look like. Okay. So please don't press anything. I don't annotate on the slides, okay? Because otherwise I will have to keep going back and forth. Okay, so right. So electromotive force, the definition for electromotive force is the work done by a source, okay, in driving 1 coulomb of charge around a complete circuit. Okay, that's the definition of it lah. Okay, so in a complete circuit, for example, like this whole thing, right? Okay, the work done by a source in driving 1 coulomb of charge around a complete circuit. And the unit for EMF is the same as potential difference, which is volt or joules per coulomb. Okay, so I want you to understand also the difference between the open circuit and the closed circuit. Okay, the open circuit is like this. When you just have 1 voltmeter connected to the dry cell, okay, which was the same situation as we had when the switch was closed. Okay, so this is what we call an open circuit because number 1, the switch is off, and number 2, the voltmeter is only connected to the dry cell, which is why there is a reading. Okay, which is why there is going to be a reading in an open circuit. Cuma di sini memang tiada reading because you learned this when we were doing Ohm's law. Okay, there is going to be a reading here in an open circuit. Okay, and then in a closed circuit, okay, closed circuit ini kita sudah biasa. Okay, if let's say I attach a bulb over here, okay, it becomes the same situation as as Ohm's law. Okay, so in this way, we find that, okay, if you take a look at the 2 readings, in the open circuit, the reading of the voltmeter is bigger than in a closed circuit. Okay, the reading of the voltmeter in the closed circuit. Okay, all these observations are very important. Okay, so this question we need to ask now, what does the label 1.5 volt on the battery mean? Okay, the voltage label on a battery or cell indicates its EMF. Okay, the original amount of potential difference. Okay, sorry, the original amount of voltage in a new battery, okay, for example, is 1.5 volts. Okay, and that is the EMF, which means no matter how much you do, no matter what you do to the circuit, the total voltage cannot be more than the EMF. I'm going to repeat this. No matter what you do to a circuit, kau tambahlah berapa banyak microwave lah, peti sejuk lah, apa-apa kan, the total voltage it cannot be more than the EMF. Okay, when you understand this, then this whole thing will make sense much later. Okay, the label 1.5 volt on a dry cell indicates the EMF of the cell, which is 1.5 volts. Okay, so technically, a cell has an EMF of 1.5 volts. Okay, this is already according to the definition. If a flow of 1 coulomb of charge produces 1.5 joules of electrical energy to the whole circuit. Okay, meaning whether it's an open circuit or closed circuit, it will only be able to produce 1.5 joules for every coulomb of charge, okay, that is flowing. So the first thing, I know there's a lot of words in here and it's a little bit too early in the morning for some of you that just woke up at 9:59 a.m. It's okay. I just want you to take home this one thing, that the voltage that we see in the battery, when you go to the store and you buy the battery, okay, yang kau nampak, sometimes it's 9 volts, sometimes it's 1.5 volts, that is the EMF. Okay, if you want to put it simply, that's the amount of voltage that the battery can supply. Okay, the maximum, and we call that the electromotive force. Okay, the big one now. Okay, any other reading, okay, kenapa dia drop? Okay, kenapa dia berkurang? From the open circuit, there is this amount, and then when you close the circuit, when you turn on the switch, the voltage will drop. Okay, why that happens is in the next slide, which I will show you. Okay, so in an open circuit on the left side, okay, this is what you will see. Okay, the cell is connected only to the voltmeter. Okay, so there's no current flowing through the circuit, just like the one that I showed you earlier over here. Okay, in an open circuit, there's only current flowing here. There's no current flowing here at all. Okay, so okay, so the voltmeter reading is 1.5 volts, and that is the EMF. Okay, so important thing to remember, how do you know whether the reading is the EMF reading or the potential difference reading? It is, if it is in an open circuit, okay, if it is in an open circuit, then it is the EMF. Okay, when there's nothing else flowing, in any other circuit, okay, then it is the EMF. Secondly, in the closed circuit, okay, let's say I attach everything, this one, okay, this is similar to our circuit that I showed on the board over here. Okay, it's just that dalam PowerPoint itu, the voltmeter put down here lah, but it's the same thing. Okay, it doesn't matter whether I put it up here or down here, it still means the same thing lah. Okay, so we're going to find that in a closed circuit, close this circuit. Okay. In a closed circuit like this, okay, this is a closed circuit. Okay, in a closed circuit, okay, current is going to flow through the whole circuit. Okay, current flows over here. Okay, then you find that the reading of the voltmeter will drop a little if a lamp or a resistor or a constant wire or a fridge or a microwave or whatever lah. Okay, you put it in series to the cell. Okay, secara sesiri, it's one flow only. Okay, so if the reading is 1.2 volts, okay, as I said just now, originally the battery reading is 1.5. Okay, then when you close the circuit, the same battery reading becomes 1.2 volts. Okay, and we find that this 1.2 volts, if I put another voltmeter over here, I hope you can see this, the cursor that I'm showing. Okay, if I put another voltmeter here, sorry. Okay, I'm gonna draw this. Okay, if I put another voltmeter here, oh, please forgive my ugly. Oh no, sorry. Okay, so, hey, This is taking too long, kan? Okay, anyway, if I put another voltmeter over here, yeah, it's going to take too long. Okay, if I put another voltmeter over here, okay, I'm going to get the same reading. Okay, pretty much as I was showing you here. Okay, if I put this voltmeter here, I put the voltmeter here, I'm going to get the same reading, which is 1.2 volts. It must be less than the EMF. Okay, because okay, because the current is already flowing in the circuit. Okay, so coming back to this. Okay, so if you notice, they're originally 1.5 volts. Okay, and then there's this 1.2 volts over here. Okay, so the question is, there's a difference in voltage reading, which is, if you count now, 1.5 minus 1.2 is 0.3. So the question is, where did the 0.3 volts go? How did the 1.5 volts of energy, okay, how come it only 1.2 volts is used? Where is the 0.3? Okay, there's no balance to it. Where did the 0.3 disappear to? Okay, and this is where we are introduced to this section now, which I'm going to call this one. Okay, there's this drop in potential difference. Like just now, there was a 1.5 and then it became 1.2. There's a drop of 0.3. Okay, in this experiment, which you will do after we go back from this MCO, okay, you'll find that when the position of the switch is open, okay, this is basically the experiment that you're going to do, but it's a shortcut. The procedure is already shortcut lah. So the voltmeter now dipasang di sini dekat dengan battery. Okay, then when I off the switch, okay, the switch is open lah. Okay, the circuit is open. Okay, so obviously there's no reading of the ammeter, but there will be a reading of the voltmeter. And I said just now, this reading is also known as the electromotive force, the EMF. Okay, we find that the voltmeter reading is 3 volts. Okay, but suddenly in a closed circuit now, we find that the voltmeter becomes 2.6. Okay, which means that there is a drop. Okay, there is a drop in potential difference. And this drop in potential difference is 0.4 volts. Okay, so the question is, why is there a drop in potential difference? Okay, so this is the thing that we are introduced to something new. Okay, the drop in potential difference across the cell is caused by the internal resistance of the cell itself. Okay, I just want to show you that. Okay, let's say we take this battery and we zoom in a lot more. Okay, we zoom in on the battery a lot more. Okay, same reading because parallel. Yes, same reading because parallel. Thank you. Good question. Somebody asked me, kenapa ini dan ini same reading? Correct, because this and this is arranged parallel. Yeah, it's arranged parallel, but also because there's only one flow. Okay, there's only one flow in the circuit, so the voltmeter reading is the same. Okay. Now, let's say if I zoom in on the battery, okay, this is the battery. This is the terminal of the battery, okay. So this is the battery, and we find that, okay, alongside connect, okay. And if you remember, inside the battery, of course, there's this rod over here, and all this one, do you remember what all this is called? Have you ever opened inside the battery before? Okay, you see all this macam serbuk lah. Okay, all these are electrolytes. Okay, we're going to the chemistry world now. Okay, so all these electrolytes actually provide resistance. Think of an electron or think of a charge flowing through these electrolytes. It's obviously going to encounter some resistance, okay, which is why we call this the internal resistance. The internal resistance is because it is the resistance that is caused by the battery itself. Okay, and we find that because of this internal resistance, internal resistance is what causes the voltage drop. Okay, I'm going to write it out here because it's the most important one. The internal resistance, okay, causes the voltage drop. Okay, the singular most important thing that we need to remember, okay, when we're talking about internal resistance, this internal resistance because of the electrolytes in the battery. okay, is what causes that voltage drop. So if you remember our situation just now, originally is 1.5 volts when the circuit is open. Okay, when the circuit is open, the EMF is 1.5 volts. When I close the circuit, the voltage becomes, the voltage becomes 1.2 volts. Okay, so this 1.2 volts, because of that, there is a voltage drop. Okay, and the voltage drop we find is 0.3 volts. Okay, and if I know the voltage drop and I know the current that is flowing in the circuit, I can find how much is my internal resistance of the battery. Okay, in a while we're going to cover all this, okay, all this calculation part, and I'm going to attempt to teach you a simpler way rather than just depend on the formula, because the formula I feel is too complicated. Okay, we're going to see if there's an easier way to count the internal resistance by just using our logic and what we have learned before. But the first thing that the don't know how many of thing okay, that you need to remember is internal resistance is caused by, internal resistance causes this voltage drop. And it is because the electrons have to go through the electrolytes in order to come out the other side. Okay, so all these electrolytes are memang dia akan memberi resistance to the electrons. Okay, that's why it's called internal resistance. Internal sebab in the battery. Okay, the external resistance, okay, external resistance will be in cases like, okay, external resistance is this the bulb, the constantan wire, the resistor, the microwave, the peti sejuk, everything okay, all this is external resistance because it's outside the battery. And we've learned about external resistance in the last two subtopics. Okay, we talk about series circuit, we talk about Ohm's law, all these are to do with external resistance. So this subtopic is talking about internal resistance. Okay, so this is a comparison. This is the comparison of EMF and potential difference. Okay, EMF is this, indicates this one. Both are measured in joules per coulomb or volts. Okay, but this is the thing. Electromotive force is represented by the voltmeter when the switch is open or an open circuit. Okay, potential difference yang kita sudah biasa buat, okay, the reading of the potential difference is represented by the voltmeter reading in a closed circuit. Okay, bila kita sudah turn on the switch, when the switch is closed, okay, and then the reading of the voltage there is the potential difference. Which is why, ladies and gentlemen, I want you to stop using the word voltage. Okay, because there's a difference now, you know. Which voltage are you talking about? Are you talking about the electromotive force or are you talking about potential difference? Okay, that's why I prefer you use the word potential difference rather than voltage, because voltage can refer to electromotive force, voltage can refer to potential difference. The unit is the same, the unit is volts. Okay, but we try to avoid the word voltage, especially when we're talking about small circuits like this. Okay, we talk about electromotive force or potential difference because both have the same unit, but both are very different. Okay, electromotive force is in an open circuit. Potential difference is in a closed circuit. Both are voltage. So I try not to use the word voltage anymore, okay, in the future. Okay, before we go to the calculation part, I just want to ask if there's anything that you want me to repeat or anything that you have any questions for. Because once you understand this, once we kind of get this, okay, then I can try to start to teach you how to do the calculation. This part is just understanding how to find the electromotive force and the internal resistance. Any questions so far? Just wondering. Okay, boleh lah. Okay, thank you. Anybody else really? Got no questions? If you have any questions, anything you don't understand, please ask or please type in the chat box. Okay, so that okay, well, everybody seems to be okay. All right. So let's talk about the calculation part. Okay. I just want to remind you that this is the okay. Sorry, we're talking about subtopic 2.4. Okay, yang baru masuk ini, kita sedang bercakap tentang subtopic 2.4 and ask later, Haris. Okay, I want to mention that this is the experiment that you're going to be doing the moment we get off from this MCO. Okay, so I've already mentioned this. Please prepare the experiment report for this. This is a non-hypothesis experiment because you just have to do this and you have to draw the graph later, okay, which we'll talk about in a while. Okay, so this next part now, okay, as I said, internal resistance is the resistance against the moving charge due to electrolyte in the source of a cell. Okay, so it is the resistance because of the electrolyte. Okay, so work is needed to drive a charge against the internal resistance. You need energy to go against the electrolytes. Okay, so that energy that we use up, okay, is the one that causes the potential drop. Okay, this equation I'm going to skip for now because I need you to do the experiment in order for me to explain this part. Okay, so once we have done the experiment, then saya akan kembali kepada ini. Okay, but basically this graph is the y-intercept is the electromotive force and the gradient, the negative of the gradient is the internal resistance. Ini adalah cara mengira EMF dan internal resistance dengan menggunakan graph. Okay, which I will cover much later when we have done the experiment. Because if you have not done the experiment, this will be very difficult. Okay, but I'm just going to try to answer now this part. Okay, so before that now, I want to make this this relationship now. Okay, so we find that in an open circuit now, okay, okay, the only thing that you have is the electromotive force, okay, which is the total amount of energy that you have. The reading, sorry, the bacaan that you see on the battery are 1.5 volts, 9 volts, all those are the electromotive force. Okay. Then now, when you close the circuit now, okay, sorry, when you close the circuit, we find that the electromotive force drops to become the V, okay, the reading of the voltmeter. Okay. Voltmeter reading. Okay, this is the EMF. Okay, so in the end, how do we find the potential drop? The potential drop will be the electromotive force minus the voltmeter reading. Okay, this is what we have established so far. Okay, electromotive force minus the voltmeter reading equals to the potential drop. Now, if I move this over here, I'm going to get the electromotive force equals to the voltmeter reading plus the potential drop. Okay. Now, when we were doing Ohm's law, we also learned that the voltage equals to the current times the resistor. Okay, this is the one that we learned last time. Voltage equals to current times resistor. So, for example, in the closed circuit, if I know what is the current and if I know what is the resistor, I can say that this is also equals to IR. Okay, the current and the big resistor. Either the resistor lah, or the concentrator wire lah, the menthol lah, the peti sejuk lah, microwave lah, resistor lah. Okay, the resistor of the big thing. Okay, and at the same time, since this is IR, this also must be I, but I'm going to call this times a smaller r because this is the internal resistance. Okay. So if I know the resistance of the big one, and I know the electromotive force, I know the current, I can actually count the internal resistance, okay, the small one. Okay. The third thing that you need to understand is that in an open circuit, in a closed circuit, let's say I'm going to put the bulb over here. Okay. Now remember this, sorry, I'm going to put this as a resistor. This is a resistor. Okay, and then in here, remember, there is a very tiny resistor. So I'm going to draw tiny resistor. Okay, because of the battery. Okay, battery. This is a resistor. Okay. Now, if we look at this circuit, okay, I have already taken out all the unnecessary things. If you look at this circuit, okay, I'm going to answer this question. Somebody asked me, what is the difference between the big IR and the small IR? Okay. Just a while. Okay, 1 minute I'll answer. If you look at this circuit, we've learned this in 2.3. This is actually a series circuit. Okay, both the resistors are arranged in a series, which means that the current that is flowing in the battery is also the same as the current flowing in the resistor. And this helps us so much. Okay, because these two resistors are in a series, okay, the current that is flowing in the battery is the same as the current that is flowing in a resistor. Okay, so actually this and this, okay, same value. So the only difference now is the big R and the small r. This is the big R, okay, because this is the resistor because of the resistor. Sorry, this is the resistance because of the resistor, because of the mantle, because of the microwave, because of the petissejouk. I like to use microwave and petissejouk, I don't know why, but anything that you put here, okay, will have a resistor. The constant wire, okay, will be a resistance. Okay, the small r is the okay, the very tiny resistance because of the battery. Okay, so when you combine these two together, the total voltage must be equal to the EMF. Okay, when we do the calculation questions, okay, I'm going to. This is the explanation. When we do the calculation questions, I hope that it will make a little bit more sense. Okay, I hope I answered the question to the person that asked me this question. Apa beza IR besar dan IR kecil? IR besar is the resistor punya resistance. IR kecil is the internal resistance of the battery. But the I is the same because both are in series. Okay, this resistor and this resistor is in series. Dan kita sudah belajar litar sesiri, the current must be the same. Okay? And that helps us a lot because it makes it easier for us to count the internal resistance. Okay, all right. I'm going to start with the first contoh soalan. Okay, not this. Okay, so we have a voltmeter connected. Okay, so the question is, a voltmeter connected directly across a battery gives a reading of 1.5 volts. Okay, listen now, a voltmeter connected directly across a battery gives a reading of 1.5 volts. The question you need to ask is, this 1.5 volts, is it E or is it potential difference? Okay, obviously, because the next one says the voltmeter reading drops to 1.35 volts when a bulb is connected to the battery and the ammeter reading is 0.3 amps. Okay, find the internal resistance of the battery. So I'm going to put all this information here. So we find that this is the bulb. So we find that in this one, when the switch is open, okay, the reading is, oh dear, I forgot, 1.5 and 1.35. Okay, so the reading is 1.5 volts. Okay, open circuit, therefore E must be 1.5 volts. Okay, we established this first, sorry. E equals to 1.5 volts. Okay, then when I close the circuit, okay, we find that this reading becomes 1.35 volts. So the question you need to ask yourself is, this 1.35 is now known as the V. Okay, V is 1.35 volts. So immediately from this, right, when you know the E and you know the V, count first the voltage drop. Okay, voltage drop is E minus V. 1.5 minus 1.35 is, faster, 1.5 minus 1.35. Yeah, because I'm doing a lot of talking, so you need to press the calculator for me. How much is the voltage drop? Okay, 0.15, so 0.15 volts. Okay, then remember, the current they say is, oh dear, I'm so forgetful. The current is 0.3. So remember, current is the same for both. Same for here, same for here. So actually, besides the internal resistance, I can also count the external resistance if I want. Okay, but I'm going to count the internal resistance first. Okay, so the internal resistance, V equals to IR, 0.15. Remember, this V is the V drop, okay, equals to 0.3 times R. You pin that over, you get R equals to 0.5 ohm. Okay, I would prefer using this method because it helps us to separate both the resistance. I don't particularly like the formula that they give. Okay, I know the book gives the formula and it's like, wow, it's so simple, just put everything in. But it doesn't help us to understand the concept. Okay, the current is the same. And although the question is not asking, I'm going to ask, how much is this resistance? Okay, so I can. By using, once again, Ohm's law, V equals to I big R, because This V is for the big R. The V drop is for the small r resistance. So this is 1.35 equals to 0.3 times R. How much is my big resistance? Quick, 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 count, count, count. How much is my big resistance? 4.5, okay, 4.5 ohms. Okay, and this is kind of a table that I usually like to use. Okay, oh, so ugly, sorry. Okay, E equals to 1.5 volts. Okay, then I separate this out. Okay, I usually like to use this method to count because this V is because of the reading of the ammeter. Sorry, this V is because of the big resistance. This is the internal one. Okay, the current is the same for both, and the E, tengok 1.5 must be equal to 1.35 plus 0.15. If you do this method, any circuit you can count. Okay, the internal resistance. Okay, I know a lot of people will teach you this one. This formula equals to V plus IR. Okay, or E equals to I and then the big R plus the small r. Okay, which honestly, if you ask me, I think it's very confusing. Okay, because I don't know when to use which one. Okay, for me, it's always easier to count the voltage drop first. Once I have the voltage drop, I have everything else. Okay, so it's up to you. Okay, I'm not forcing like, oh, you must follow my way. Okay, but I find that, oh, when I put it in the table, it's easier for me to understand. Okay, let's try the second question now. Okay, second question. A circuit contains a cell of EMF 3 volts and internal resistance. Okay, so dia tak bagi tahu apa-apa selain daripada the EMF. Okay, then the external resistor has a value of 10 ohms. Okay, and the potential difference across it is 2.5 volts. Okay, so I'm going to put in all these values. The EMF is 3 volts. Sorry, I'm going to use green color. Okay, external resistor has a value of 10 ohms. So R equals to 10 ohms. Okay, and the potential difference across it is 2.5 volts. Okay, find the current value I and the internal resistance R. Okay, so this is the information that I have so far. The things that are in purple are always going to be there, always. Okay, saya kekalkan di sana lah. Whenever I do a calculation, I always use this. So, if my EMF is 3 and my voltage is 2.5, immediately I know how much is my voltage drop. Is 0.5 volts. No need to think already. Okay, my voltage drop is 0.5 volts. Okay, now, if I'm given these 2.5 volts and my 10 ohms, I can actually count my current by using Ohm's law once again. Okay, so this is 2.5 equals to I times 10. Can somebody tell me the value of I, please? No, I don't think it's 4.5. I think it's 0.25. Okay, 0.25 amps. I'm going to put this here, 0.25 amps. Remember, current is the same for both. So if I have the current and I have the voltage drop, I can count the internal resistance. V equals to I small r, because I want to count the internal resistance. Okay, so 0.5 equals to the current 0.25 times R. So what is my R? 2. 0.5 divided by 2 ohms. 2 ohms, okay, 2 ohms. Okay, and there you have it. Okay, again, I believe that the key to understanding this subtopic is knowing how to count the voltage drop and understanding that the current is the same and using Ohm's law. Once you have these three in hand, this subtopic is really kacang putih, hitam, hijau, dan merah. Okay, it's very, very easy. All right, next question. I'm going to show the next question to you, and I want you to try to do it yourself first. Wow, like so hebat. Maybe some of you are going to use this opportunity to go to Rehat. Okay, guys, try not to do the whole thing in order. Okay, don't do A and then B and then C. Just fill up the jadwal first, and then after that you answer A, B, and C. See if you can do it on your own. Okay, I'm going to give you maybe about 3 minutes. okay, to do this. Oh, sorry. Okay, Jeremy is sharing his answers with everyone, so it's okay. I guess you can this one. Big resistance 4.5. Sure or not? I'm just going to put this up here as some of your answers. Okay. Oh dear. Not sure. Some people got 5. Okay. Apa baller ni? Okay, some people got 5. Don't worry, we'll verify this in a while. Okay. Even if it's funny, hello, focus. Who's gong? Okay, sorry. Focus, focus on the question, people. Stop making comments. Okay. Focus on the thing that you can count first. Don't focus on the question. Okay, look at the table. Focus on what you can count first. Okay, remember Ohm's law. A is 0 is wrong. Actually, depending on where the voltmeter is. Yeah, it can be 0, it can be 2. Yeah. A is probably 2 volts, but it's a very tricky. Okay, later I will ask. Later I will listen. A upper 2. Oh, sorry. What am I doing? Oh, okay. Apa ni? Okay, so now we're going to come back to this. All right, so this is the information that you have. You're given the EMF is 2, the current that's flowing is 0.4 amps. Okay, and then you're given the internal resistance 0.5, and that's it. You're not given anything else. Okay, so instead of focusing on the question, as I said just now, instead of focusing on the question, try to focus on what we can count first. If we have I and we have R, we can actually count the V drop. Okay, so the V drop, oh sorry, I'm going to use green. Okay, the V drop is equals to 0.4, the current, because remember, in a series circuit, the current is the same. Okay, current is 0.4 times 0.5. What is my V drop? Okay, the V drop is 0.2. 0.2. Okay, fine. I'm going to trust Ethan. 0.2 volts. So if my V drop is 0.2 volts, automatically, people, I know what is my voltage across the circuit. Okay. Okay, 2 minus 0.2 is 1.8 volts, because these two must be equal to EMF. Cannot be more. Okay. Now, once I have my 1.8 volts here, and I have the current again, I can count my resistor. Okay, 1.8 volts, 1.8 equals to 0.4 and R. What is my R? Okay, R is 4.5 ohm, which means Jeremy's answer is 1 is correct. Okay, so again, don't focus on the question, focus on what you can count. Okay, and always hold on to V equals to IR. Because once you fill this out, then you can answer the question very easily. Okay, the only problem now is question A. Okay, question A is a bit tricky because they say what is the voltmeter reading in an open circuit. Okay, my question to you is, okay, I'm going to run this off. Okay, my question to you is, macam mana dia punya rupa bentuk open circuit? Okay, if let's say this is my battery, and then they say the resistor is 4.5, right? Okay, so 4.5 ohms. Okay, and then I have the open circuit like this. I'm going to have the ammeter reading here. Okay, the question is, if my voltmeter is here, what is my reading? My reading here will be 2 volts. Okay, that's correct. But if my voltmeter is here in an open circuit, if my voltmeter is here, what is this reading? This will be 0 volts. Okay, because the current is not flowing. So because the question doesn't state now where they put the voltmeter, we're going to assume okay, we're going to assume that the voltmeter is here because ini berkaitan dengan internal resistance and electromotive force. Okay, but it's very important to look and see the position of the voltmeter. Kalau ada gambar raja, means you have to see where the position of the voltmeter is. If the voltmeter is here, then in an open circuit, this will be 2 volts. But if the voltmeter is down here, and in an open circuit, this one will be 0. 0 volts. Please be careful with that. All right. Okay, next question. I think there's only about 2 more questions left. We'll probably finish early today. Oh, is my video lagging? Am I lagging? Am I lagging? Am I lagging? No? Okay, it's just Jeremy. Fine. All right. So, next question. Again, do the same thing. Okay, fill up the table. Okay, this is the question. Look at the circuit. Look at the information given. Okay, and try to fill up. Don't worry about the question now. Fill up what you can fill up. Isi apa yang kamu boleh isi. What is 22.8, Jeremy? 22.8 what ringgit? No, sorry. 22.8. Smiley face with laughter and tears. Come on. Make sure you give me the unit. 22.8 ohm. What are we talking about? The big R. So some people are saying the big R is 22.8 ohm. Any other big answers? Big answer. Any other answer? Are you sure it's 22.8? It seems like a very weird number to get though for resistance. Voltmeter reading 11 and 4 volts. Huh? 11.4. The voltage drop is 11.4. Which one, the voltmeter reading or the voltage drop? Voltage is 11.4. Voltage drop 0.6. Okay, I'm going to put here 11.4 volts. Yeah, don't worry, we'll verify this in a while. 0.6 voltage drop. Okay, good, good, good. You seem to be getting the answer, but I'm not sure whether it's true. Don't you think all these numbers are very funny? 22.8. Jarang kalau kita dapat 22.8. Are you sure you didn't calculate this wrongly? Bukan deck. What's bukan deck? Voltage drop berapa dia drop? Voltmeter reading itu voltage drop. That's very wrong. Voltmeter reading is not the voltage drop. Voltage drop you have to count separately. The voltmeter reading is after the voltage should have dropped. Okay, so be very careful with that. Okay, good that you can detect your mistakes early. All right, so let's see what we can do. So EMF is given as 12 volts and you're only given the current 0.5 amps and the small resistors, which is 1.2. Okay, you have the current, you have the resistance, you can count the voltage drop. Voltage drop equals to 0.5 times 1.2, which will give you 0.6. Okay, 0.6 volts, immediately I can count. What is my voltmeter reading? 12 minus 0.6 will give you 11.4 volts. If I have 11.4 volts, people, and I have the current, I can count the resistance. V equals to IR. V is 11.4 equals to 0.5 times R. And you will get R equals to 22.8 volts. Okay, it's too simple a method. I feel that it's very decent. Okay, yeah, okay. So it works both ways, guys. If I know what is my voltmeter reading, I can count the voltage drop. If I have the voltage drop, I can count the voltmeter reading. The important thing to remember is that it must not exceed the EMF. Okay, because there's nowhere in this world kamu bekalkan tenaga kan, lepas tu yang kau guna adalah lebih daripada tenaga yang kau pakai. It doesn't make sense. You eat 2 pieces of bread, you will probably tapian 2 pieces of bread. Okay lah, no lah, you won't lah. But the total thing that you tapian keluar and the total thing you use must be equal to 2 pieces of bread. Okay? Yeah, Eugene. Sir, I have to rejoin black screen on Sir screen. Sorry, can you see me? Can everybody see me, or am I a black screen to everyone? Wow, yes. What's wow, yes? Oh, I'm black screen. Oh, can see. Oh, okay. Very yes, yeah. Okay, thank you. All right. I think we have another question, which is the last one, I think. Okay, so this one I'm just going to show it to you because it's part of the slides. So I'm just going to show it to you. So a cell of EMF, E, and internal resistor, okay, is connected to a rheostat. The ammeter reading, yada, yada, yada. This is the experimental question. Kalau kau sudah buat eksperimen kan, then this graph will make sense to you. Okay, but before we answer this graph, before we answer this question, I just want to show you a few things. When we were doing Ohm's law, okay, okay, we were doing the same graph, V against I. Okay, sorry, VB against IA. Okay, but the graph we found was a directly proportional graph. Okay, this was Ohm's law. And when we count the gradient, okay, the gradient is actually equal to the resistance. Okay? The resistance of the menthol, the resistor, the constant wire, the peti sejuk, the microwave, whatever. Okay, whatever they put here. Okay. Okay, so if I want to know what is the resistance of this bulb, I count the gradient. This is Ohm's law. Okay. But for the EMF experiment, the electromotive force experiment, we are going to plot the same graph, dB and IA. But we're going to get this kind of graph instead. Okay, because of the position of the voltmeter. Okay, remember in an EMF circuit, okay, the position of the voltmeter, okay, is no longer down here, but it is up here, which is why you will get this kind of graph. Okay, now if we learn our anything from linear law, okay, if we learn anything from linear law, I can actually form the y equals to mx plus c. I bet you never thought that this would come in this chapter, right? Yeah, but anyway, it's coming in this chapter. Y equals to mx plus c. Yeah? Our y is volt. Okay, volt equals to our m, I don't know. Okay, our x is I. Okay, plus c. Okay, so tiba-tiba the linear law masuk. Okay, so there are two things I want to teach you about this. The first one is the c, okay, the y-intercept over here, okay, is known as the electromotive force. Okay, because when there is no current, the voltage that you get is the maximum voltage. Okay, and that is the electromotive force. So I'm going to rewrite this. V equals to MI plus E. Okay, and then on top of that, once again, if I calculate the gradient, okay, same like this one. If I calculate the gradient, I get the resistance. If I calculate the gradient, I will also get the resistance. Okay, but since the line is in this direction, the resistance will be the gradient will be a negative value. Okay, so this is the equation. This is the equation for this line. Okay, which we will find. But if there's anything that I want you to take away okay, from this, it's not the formula. Don't bother with this formula. Okay, it's just macam mana kita bina dengan menggunakan linear law yang kita sudah belajar. Okay, but what I want you to know is that how, if I give you the graph, how do I determine the EMF? Okay, determine EMF by finding the y-intercept. Okay, this is the first thing. If I have this graph, I determine the EMF, which is the peak voltage, okay, by determining the y-intercept. Secondly, you can determine the internal resistance. Okay, R by calculating negative gradient. Okay, the gradient you're going to get is negative. So negative, then you get positive. Okay, I want you to hold on to these two. Okay, before we answer this last question. Okay, we determine the EMF by this graph by finding the y-intercept. And we determine the internal resistance by calculating the negative of the gradient that you find. Okay, which brings me to this last question. Okay, so the cell EMF, yada, 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 and then you're given this graph. So from the graph, determine the electromotive force, E. And as I said earlier, the electromotive force is the y-intercept. The y-intercept is 6. Therefore, the E is actually equals to 6 volts. Okay, all right. Secondly, the internal resistance of the cell. Okay, take a look at these 2 points. This is 0.06 and this is 0.22. Okay, so I'm going to do this. This is 0.6. This is 0.6, and the one that they bought this in okay, this is 2 and 2. So the internal resistance is negative of the gradient. Okay, 6 minus 2 over 0 minus 2, which will get negative 4 over negative 2, which will give you 2. Okay, so we will look more into this when we do the experiment after we come back to school. Okay, but for now, you should be able to answer the exercise questions that I give you if you hold on to these two. Okay, if you find the y-intercept, means you found the EMF. Okay, and if you find the negative of the gradient, okay, you will find the internal resistance. Okay, if you want, you can make a small note here and say that the internal resistance must be a positive value. There's no such thing as negative resistance. Okay, in case you forget this. Okay, and that's actually all for today. Yeah, this subtopic is very simple actually because it's just calculation. Once you know how to calculate, it is a very simple subtopic. Okay, a lot of people don't like this subtopic because of the formula, but I'm choosing not to teach you the formula, instead to teach you how to count based on the jadual yang saya bagi tadi lah. Okay, any questions from anyone? If anybody has any questions, you should ask now. Maybe some of you have already tried to start answering the worksheet. You should try to answer the worksheet. Macam tiada. Okay, can I go home? You are home, Tong. Sometimes I don't know. Okay. Lawak Jo. Okay, balik jaka kau. Yeah, I know. Hello, Jeremy. You're pot calling the kettle black. You also like to always go home one, okay? Okay, so if there is nothing, I want to just end by with a few announcements. First of all, I want you to please take note of the things that you have to do before the 1st of April. First of all, prepare the experiment report to determine the electromotive force and internal resistance. Okay, it is a non-hypothesis experiment. Okay, and you can find the experiment in the blue book, page 405. For those of you who have the blue book, okay, the reference book. Okay. Secondly, watch the video over here that I'm posting to gain an idea of how to do the experiment, so that when you start school, you don't look lost, like macam tidak pernah pergi sekolah for 2,000 years. Okay. Okay, then thirdly, okay, this Kahoot quiz, I don't want you to start doing it yet unless you've already finished learning 2.5. Okay, but wait until we finish the class on Friday, then you can do the Kahoot quiz. Okay, then this 4, okay, this 4 is the important one. Complete the 2.4 and 2.5 homework, okay, which I've already posted here. You can either print it out, okay, or you can copy the question on post-it paper, but I only want to see your work. Okay, kamu punya penyelesaian semua, I want you to scan it or take a photo of it and upload the assignment into this section. Okay, so, sorry, electricity here, 2.4 and 2.5 homework. Okay, so you will need to attach stuff. Okay, so let's say for example, okay, so by the time I see this, I need to see one whole row of attachment, attach everything. Okay, so it's probably going to take you maybe 2 or 3 pages per person. Okay, so just take a photo. If you don't have cam scanner, doesn't matter, you take a photo, you can post it up on here so that I can check it during our confinement month over here. Okay, so please take note of all this homework that you need to do and you need to prepare before the 1st of April. Our last subtopic, 2.5, will not have any experiment. So that's why this one is memang menyeluruh lah. Okay, for 2.4 and 2.5, this is all you need to do. But I want you to prepare 2.5 because 2.5, there is kind of a lot of calculation going on. Okay. Yeah, so I've posted the assignments here. Please make sure that when you have finished the assignment, don't forget to turn in. Okay, I always have to remind people to turn in this one. Okay, so if there's no more questions, really, any more? No more questions? I'm going to stop the recording now.